Have you ever looked up at one of those towering skyscrapers? The ones that are just a giant wall of glass reflecting the clouds and wondered, how does that not just shatter in a huge storm? We see these massive buildings every day, but we don't really think about the invisible war they're constantly fighting. So how do they do it? Let's get into the incredible science that keeps our city standing.
I mean, it seems impossible, right? But the answer? It's not magic. It's actually some surprisingly straightforward physics. It all starts with turning that invisible push from the wind into a number you can actually work with.
So first things first, we have to stop thinking about wind as just weather. For an engineer or an architect, wind is a load. It's a physical force that's pushing against a building, just like gravity is pulling it down. And to fight a force like that, you've got to be able to measure it. And this is the key concept right here, wind pressure. See, it's not just about how fast the wind is blowing. It's about how much force that wind is putting on every single square meter of a building's surface. But okay, how do you actually calculate that? Well, luckily, engineers have a really powerful and, honestly, a surprisingly elegant tool for this. It's a formula that lets them translate the speed of the wind into the pressure it creates. Let's take a look. Here it is. It looks pretty simple, but this little equation is fundamental. P is our pressure, V is the wind's velocity, its speed, and that little squared symbol, that's the secret sauce. We're about to see why it's so important.
So let's just break this down. P is the pressure we're trying to find, and we measure it in something called pascals. V is the wind speed, in meters per second. And that number, 0.613, that's our constant. It's basically tied to the density of air. You can think of it as the special ingredient that makes the whole calculation work. Okay, theory is great and all, but let's make this real. We're going to plug some numbers into this formula and see just how powerful the wind can actually be.
Let's imagine a really strong wind, okay? We're talking 40 meters per second. That's about 90 miles per hour or 144 kilometers per hour. That is definitely strong enough to cause some serious damage if you're not prepared for it. Okay. Remember that squared symbol? This is where it gets really interesting. We square the velocity first. And this is so important because it means the force of the wind grows exponentially. So if you double the wind speed, you don't get double the pressure. You get 4 times the pressure. It's a total game changer. So 40 times 40, that gives us 1600. That's our v-squared value. Easy enough. Now let's plug that back into our main formula. All right, now we take that 1600 and we multiply it by our air density constant, that 0.613. This is the step that actually converts all the kinetic energy of that moving air into a real pressure value. And there's our answer, 981 pascals. So what does that actually mean? Well, it means that our 90-mile-per-hour wind is pushing with a force of about 220 pounds on every single square meter of that building. Every one. But that's the thing, right? That's a lot of pressure, but it's still just for 1 square meter. And skyscrapers are, well, they're a lot bigger than that. So what happens when we scale this up to the size of an entire building facade? Let's just say we have a decent-sized glass facade, maybe with a total area of 1,000 square meters. You can just picture a wall that's maybe 20 meters wide and 50 meters tall. So to get the total force, it's pretty simple. We just multiply the pressure per square meter, our 981, by the total number of square meters, which in this case is 1,000. And the result is, it's just staggering. The total force pushing on that wall is 981,000 newtons. To put that into perspective for you, that is over 220,000 pounds of force. That's like the weight of nearly 100 cars pushing against the side of the building, all at once. That's what it has to fight back against. And that's the whole point, right? This isn't just some abstract math problem. That number, 981,000 newtons, that is the actual load that architects and engineers had to design for. This is where the math literally becomes the material. I mean, this single calculation, it dictates everything. It tells engineers exactly how thick the glass has to be so it doesn't shatter. It informs the design of the entire steel frame that has to resist that massive force. At the end of the day, this simple formula is what keeps everyone inside and even around that building safe. As our source material puts it, this calculation is extremely essential. The entire integrity of the building, from the windows you look out of to the very core of the structure, it all depends on getting this number right. It really makes you think, doesn't it?
Wind is just one of these many invisible forces, like thermal expansion or soil pressure or even seismic waves that our modern world is engineered to withstand every single day. What other invisible battles are being fought by the structures all around us?